Kate and Kennedy are research scientists doing important work on alternative energy sources. Their research requires them to investigate the electrical properties of copper. They need to have their machinists construct three solids entirely out of copper: a cone, a cylinder, and a square-based prism. Key to their research is that they need to know how many atoms make up the three solids. They will also need to know how much the copper will cost in order to properly fill out their budget requests for their lab. Each of the three solids must have the same total surface area. The square-based prism will need to have a height that is 41 millimeters longer than twice the base of the prism. The diagonal of one of the rectangular faces must measure 0.377 meters. The cone needs to have a slant height, 0.3 decimeters longer than the height of the prism. The cylinder must have a height that is 20 millimeters shorter than the height of the cone. The density of copper is 8.96 grams per centimeter cubed. The molecular mass of copper is 63.5 grams per mole. The price of copper is $12.21 per kilogram. Avogadro's number is 6.022 times 10 to the 23 atoms in a mole. How many atoms of copper do Kate and Kennedy have in their three solids? How much will the copper... So what you need to find out is how many atoms of copper do Kate and Kennedy have in their three solids? And how much will the copper cost Kennedy and Kate's lab? The square-based prism will need to have a height that is 41 millimeters. Right away, I'm going to convert everything into centimeters. The density is in grams per centimeter cubed, so I'm going to work in centimeters. It's going to be a lot easier to do that. 41 millimeters, I'm moving one step on the diagram back, so it's 4.1 centimeters. And then we have the 0.377 meters. I'm going to convert that into centimeters. I'm going to move the decimal place 2, so it's 37.7 centimeters. Here is a diagram of a square-based prism. We know that the diagonal length of one of the rectangular faces, this is square-based, so all of these four rectangles on the side are identical, right? They're congruent. The top and bottom are squares, not rectangles, so we know the diagonal refers to one of these faces. That's 37.7 as a diagonal. It's a square base, so I'm just going to call this side x. We'll need to have a height that is 41 millimeters longer than twice the base. 2 times x, and then add 4.1 to that. 2x plus 4.1 is going to be the height. This is a right angle triangle. I can use Pythagoras' theorem. A squared plus b squared is equal to c squared. My a side is x, so I have x squared. And my b side is 2x plus 4.1, so I have 2x plus 4.1 squared. I'm going to square this binomial. That's going to give me, square the first term, 4x squared, and then square the last term. 4.1 squared is 16.81. 4.1 squared. Yeah, 16.81. 2 times the first times the last. 2 times 2 is 4. Times 4.1 is 16.4x. I'm going to add my like terms. So x squared plus 4x squared is 5x squared. I'm also going to subtract the 1,421.29. That's the 37.7 squared is 1,421.29. I want to subtract it from this side, so I get 0 here. If I subtract it from the right-hand side, I also have to subtract from the left-hand side. Is equal to 0. I have a nice quadratic here, and we can solve that using our quadratic calculator or using the quadratic formula. Our A term is 5, our B term is 16.4, and our C term is 1,404.48. My A term is 5, and my B term is 16.4. And my C term is negative 1,404.48. Calculate. We get x is equal to negative 18.48. Now, x is a length, so the negative doesn't really make sense, or 15.2. We're going to discount this negative, and we're going to keep the 15.2. That means the height is 2 times 15.2 plus 4.1, which gives us 34.5 meters. Now we can find the total surface area of our square-based prism. It's perimeter of the base times the height plus 2 times the area of the base. The perimeter of the base is just going to be this x, which is 15.2 times 4, then times the height, which is 34.5, and then 2 times the area of the base. The area of the base is going to be the 15.2 squared, 15.2 times 15.2. Handy dandy calculator time.
4 times 15.2 times 34.5 plus 2 times 15.2 squared is equal to
2,559.68 centimeters squared. It's the total surface area of the square-based prism, and it's also the total surface area of all the other solids as well. Volume is area of the base times the height. The area of the base is going to be 15.2 squared. Then we're going to multiply by the height, which is 34.5.
15.2 squared times 34.5.
That gives us a volume of 7,970.88 centimeters cubed. And move on to the cone. The cone needs to have a slant height of 0.3 decimeters longer than the height of the prism. 0.3 decimeters, I'm going to move the decimal point one step over to convert it to centimeters, is 3 centimeters. I'm going to take the slant height is 3 centimeters longer than the height of the prism, and the height of the prism was 34.5. Add 3 to that, that's going to give us 37.5 centimeters is the slant height of the cone. We know the slant height, we know the total surface area, so we can put all that together and figure out the radius of the cone. The total surface area is the same as the total surface area of the square-based prism, which is 2,559.68 centimeters cubed, is equal to the perimeter of the base, which is 2 pi r, times the slant height divided by 2. These 2's are going to cancel. We're going to end up getting pi times the radius times 37.5 plus pi r squared. I'm going to subtract the 2,559.68 from both sides, and that is going to give us 0 is equal to pi r squared. I'm just going to bring this pi r squared to the front, plus 37 times pi r. Take away 2,559.68. Our A term is going to be pi. Our B term is going to be 37.5 pi, and our C term is going to be negative 2,559.68. Let's go to our handy-dandy quadratic equation calculator. The A term is pi. We end up with two values, negative 52.91 for our radius, which doesn't make any sense, and 15.4 for our radius, which does make sense. We are going to discount the negative radius and keep this radius. Now we can find the volume. The height, well, we know the radius is 15.4016, and we know the slant height is 37.5. Now we can find the height by using Pythagorean Theorem. So we know a squared plus b squared is equal to c squared. Our a is 15.4016, plus the b is the height, so height squared, is equal to the c squared, which is 37.5, so 37.5 squared. Subtract the 15.4016 squared from both sides. We end up getting 15.4016 squared is 237.21. It goes on forever. And 37.5 squared is 1,406.25. That is equal to our h squared.
37.5 squared, take away 15.4016. 3172 squared is equal to
1,169.039. So that is our h squared. Then I want to take the square root of both sides. I'm going to square root that, and that gives us a height of 34.19. Now we can find the volume of the cone. Volume is area of the base times the height divided by 3. The area of the base is pi r squared times the height divided by 3. It's going to be pi times 15.40163 squared times the 34.19122, all divided by 3. Handy dandy calculator time. Pi times 15.40163,172 squared times 34.19122,315, all divided by 3 is equal to 8,493.305, which is 8,493.305085 centimeters cubed. That is the volume of the cone. We have the volume, so now we just have to do the cylinder. The cylinder must have a height that is 20 millimeters shorter than the height of the cone. Now the height of the cone we know is 34.19. We're going to do 34.19. 20 millimeters is, move the decimal place one step, is 2 centimeters. So we're subtracting 2 centimeters from the 34.19, and that's going to give us 32.19122 centimeters. That's the height of the cone. We need to know the radius. Once again, we're going to use our total surface area formula in order to figure out our radius. So we know the total surface area. It's the same as all the other solids. It's 2,559.68 centimeters squared. It's equal to the perimeter of the base times the height. The perimeter of the base is the circumference of the circle, 2 pi r, times the height, which we just figured out. It's 32.19. It goes on for a while. Plus 2 times the area of the base, which is 2 pi r squared. I'm going to just subtract the 2,559.68 from both sides and rearrange this. So we're going to have 2 pi r squared. I wrote it as 6.28319 r squared. Then the 2 times pi times 32.19122.315.
2 times pi times 32.19122.315 is equal to
202.2632. I'm going to just feed this into our quadratic calculator again. 6.28319 and 202.2634203. Our C term is the same 2,559.68. And we press calculate. We get 2 possible radiuses. We have a negative radius, which is not possible, and our radius of 9.720. Now that we know the radius, we're going to discount the negative one. Now that we know our radius is 9.72, we can figure out the volume. So the volume of a cylinder or prism is area of the base times the height. The area of the base is going to be pi r squared times height. It's going to be pi times 9.7201 goes on squared times the height, which we've already calculated as 32.191. Go back to my quadratic calculator, get the value of the radius. We have pi times our radius squared times the 32.19122.315 is equal to 9,555.08. 9,555.0909996 centimeters cubed. Now we have the volume of all 3 solids. Let's look at our total volume. We have the volume of the square-based prism was 7,970.88 centimeters cubed. The cone was 8,493.305 centimeters cubed. For the cylinder, it is 9,555.09 centimeters cubed. If we add them all together, we end up getting 26,019.27608 centimeters cubed. We need to get the mass. The molecular mass of copper is 63.5 grams per mole, or 63.5 grams per Avogadro's number of atoms. We need to know the mass in grams. This is how many centimeters cubed we have. The density tells us that each centimeter cube has a mass of 8.96 grams. Well, we can set up a proportion with that. We could say we have 8.96 grams in 1 centimeter cubed. We know that we have 26,019 centimeters cubed. Well, how many grams is our 26,019 centimeters cubed? To get x alone, I'm going to cross multiply like that. So the 26,019.27 is going to multiply the 8.96.
26019.27608 times 8.96 is equal to
233,132.71 grams. Later on, we're going to need to know this in kilograms because the price of copper is $12.21 per kilogram. To convert grams into kilograms, you can do the King Henry died, mother didn't curse much, although it's not mother. In this case, it would be Greg. We're just going to move the decimal place 3 times like that. It's going to be 233 kilograms, or 233.1327 kilograms. We have a mass in grams, and we know the molecular mass. We can figure out how many atoms we have. Our molecular mass is 63.5 grams. A mole has 6.022 times 10 to the 23 atoms. So we can say that we have 63.5 grams in this many atoms. We have a nice proportion. We know how many grams we have of copper. We have this many grams. We just don't know how many atoms that is. I have grams on top, atoms on the bottom, grams on top, atoms on the bottom. I am just going to cross multiply. So I'm going to switch the y and the 63.5. My y is going to be over here, and I want to get it alone, so I got to get rid of the atoms. The atoms are going to come up here and multiply this number like that. We're going to have y is equal to 6.022 times 10 to the 23 times the 233,132.7137 divided by the 63.5. I'm going to take this number, I'm going to multiply it by the 6.022 and divide by the 63.5, and that's going to give me 22109.05, and it goes on for a while, times 10 to the power of 23. This number, if I move the decimal place, 1, 2, 3, 4, this is 2.21 times 10 to the power of 4, which I'm going to add to the 23. That's going to give me 2.210905 times 10 to the 27 atoms. The last thing we need to know is the price. Like, how much is this going to cost them, all this copper? We know that each kilogram of copper costs $12.21, and we know how many kilograms of copper we have. We're going to set up a proportion. It's $12.21 per 1 kilogram. We know that we have 233.13 kilograms. How much it's going to cost us, we don't know. We have an unknown amount per 233.13 kilograms. So I want to get the ZL alone. I'm going to cross multiply the kilograms this way, and then divide by 1, so we can ignore the 1. We have 12.21 times 233.1327137, and that will give us $2,846.55. Round to the nearest cent is the cost of the copper. And that's it for the ES. Have a good day.